Hi again. So we have reached exercise 4. So we have a max heap, and it contains characters. So and the max heap is the above one. It's resulted after doing some insertion and deleting of the max element, which is on the top of the tree. So and we assume that the last operation was an insert. So what are the possibilities? So which elements of these three we have inserted last? So let's go here. So obviously, so it's a heap, so we are filling the elements level by level. So the last before insertion, the tree looks like this one. So the element that we have inserted, it should be here. So obviously, so if the tree was like this without the k, so one possibility is that I have added k. This is one possibility. So this is not the only possible case, because suppose that I have added m. For example, I had k here. So if I had k here, so h is less than k, so it's feasible, and have added m here, and then I have percolated up. So m again is a possible solution. So we should check all the elements on this path. So r also, so r could be also a possibility, because let me erase those. So if r was added at the end, so so we have m here, k here, and r here. So k is correctly placed, and m also is correctly placed, and when I have added r, I have percolated up. So now let's check if t could be a possibility. So t, so if t is not here, it means that, and after percolating up, it means r should be here. This is the top element. However, and r here, and we have m and a k here. So obviously r couldn't be here, because you have o here, and all these elements should be so it should be r the maximum of all the below elements. So we have s, we have o, which are greater than r. So obviously r is not a possibility. Sorry, it means that t, to add t is not a possibility. So we could not have a t, insert t at the last operation. So the three elements that we could have added at the last, they are k, m, and r. So this is for the part 1. Then they are telling us draw the heap after the result after deleting the maximum. So we will draw the maximum. So let me erase all these. And let's draw the tree after deleting the maximum. So I delete t, and I should place k instead of t. So let's start. We have k, and let's draw everything and then do the percolation. So there's nothing here. So in k, I should find the maximum. So the maximum is s. So I will exchange both two. So s will be here and k will be here. And then I will also check k if it's the maximum between a and o. So no, o is maximum. So I will exchange also these. So we have o here and k here. And now we have a max heap. So for the last part, so they're telling us that delete the maximum operation in the binary heap result on the left, result on the binary heap on the right. So they are telling us which of the 26 letters of the alphabet could be the element labeled by a question mark. So let's go and see what could be this element. So we have this tree, which is a heap, and we have also this tree, which is a heap. So what are the possibilities of the question mark? So obviously it should be less strictly than n. So the character here, let's call it C, of the question mark should be less than n, strictly less than n. However, we have also a question mark here, which means that the question mark is greater than h, and the question mark is greater than g, and the question mark is less than u. So the question mark is less than n and less than u, so this is useless. So obviously the elements should be less than n. We have the elements should be greater than h or greater than g, so I would pick the greater than h. So the elements are I, j, k, L, and M. So those are the possibilities of the question mark. And this is it for this exercise. If you have any questions, do not hesitate to write to me. And again, thanks for watching.